We talked about this yesterday, but your general form for an exponential y equals a times b to the x. A can be positive or negative, and that will do things to the graph in terms of the direction it points. B has to be positive. A cannot be 0 because then you wouldn't have an exponential because it would wipe the whole thing out. And B has to be a positive number for this to be an exponential. B can't be equal to 1 because 1 to any power would just be 1, and that would be a straight line. So just little rules there at the bottom. I gave you guys those yesterday. Now, what I actually have graphed for you here is y equals 2 to the x. And I'm just going to write over here to the side, and you don't have to do this, but this would really be y equals 1 times 2 to the x. They just don't write the 1 in front of it. So the a value would actually be 1 there. The b value is always what's being taken to your exponent, so that would be 2. So would you guys call that growth or decay? Growth. This is growth, right? This b value is bigger than 1. So this, just in general, that's the shape of what exponential growth will look like. You already have it on there. Now, I want to show you guys the table here, how to do this in a really quick fashion. But before I do that, I'm just going to kind of highlight the x-axis here really quickly. This gets really close to the x-axis, and I know this is really weird, but it doesn't ever actually become 0. It doesn't ever actually touch the x-axis. Let me explain to you why. I'm just going to do real quick. So they've got, okay, so for example, they've got a point graphed here. They don't have any labels on the graph, but if I plugged in -4 for x, what would the y value be? So in that scenario, I'd have 2 to the -4th, right? Which would be 1 over 2 to the 4th, which would be 1 over 16. So -4 would have the y value of 1/16. And really this is just for the negative exponents. Okay, if I kept going though, the next exponent would be to the left, would be 1 over 2 to the 5th. So it'd be like 1 over 32. And then it'd be 1 over 64. And it would keep getting to be a smaller and smaller fraction. So if I plugged in 5, 1 over 2 to the 5th, then we'd have 1 over 2 to the 6th, 1 over 2 to the 7th for these negative exponents. I'm not on the screen, Phil. Okay, so these numbers, they keep getting smaller, but you always have a 1 on the top, so it doesn't ever actually get to 0. I know that's weird, but it just keeps tinier and tinier and tinier fraction. Like the next one would be 1 over 2 to the 8th. It's just a really, really small decimal. It's really close to 0, but it's technically not 0 because you have a 1 on the top. So let me show you guys a really quick way if you have to graph these, and if these are not nice points, like this was done by a computer, but if you're graphing something, if it's not on a nice point, just kind of estimate where it will be. But let me show you how to find a quick way to have the table on your calculator give you a bunch of values all at once so you don't have to plug in values individually. Okay, in general, what I'm going to ask you to do on these questions is graph at least 5 points. The typical thing to do, if we don't have any shifting or anything, we'll deal with that next week. But usually do couple negative, couple positive, 0. That'll give you a good idea of the graph. So I do like -2, -1, 0, 1, 2. Okay, so if you guys want to grab your calculator, I'm just going to show you how to get all 5 of these points in like one step. You're just going to type y equals, and you might have something in there, especially if you're borrowing one of mine, you can just clear it out. And I'm going to type in there 2, hit the lovely little caret button, and then do the x in the exponent. And the x, remember, you don't want to type the alpha key. You got to use the xt, theta, n, that button that's right next to it there to get your variable. Okay, now once you're there, just hit second graph, and that will take you to a table. And you can, I can come look at yours if it starts in a weird place or doesn't look right. But you can scroll up and down and get any x values that you want. You can't scroll on the y column, but you can scroll up and down. So this is giving me the values. Like if I had plugged in -2, what would I get? And it's telling me all in one step. So I'm just going to copy this from the table. And if you guys want to do these as decimals, or if you want to do them as fractions, the calculator is going to give it to you as a decimal here. So I'm just going to jot that table down real quick, but that's what's on the graph there. Like they have the point. Here's 2, 4, here's 1, 2, here, 0, 1. So that's just a really quick way to get points to put on a graph if you're plotting it by hand, which is what I'm going to have you guys do today. Okay, could you tell me what the domain for that graph would be? Yes, ma'am. So negative, it goes left and right forever, or if you prefer, just put the all real numbers. What would you guys put for the range here? What do you think for like the, so if you come from the bottom to the top, what would you tell me for your possible y values? It's super tricky, right? Okay, so like down here, I'm not touching any part of the graph, right? Not until I hop over this x-axis. So 0, but you don't use a bracket because it doesn't actually touch 0, so we just use a parenthesis there. And then it does go up forever. So you're going to have a horizontal line like that on all these graphs. Today it's going to be y equals 0 for all the problems. And that is actually, there's a definition for this down the page a little bit, but it's called an asymptote. It's the graph gets really close to it, but it doesn't actually touch it, doesn't go over it. For every exponential function, it's going to be a horizontal line. All the ones we're going to do today are not shifted or anything, so they're just going to be y equals 0, which is just the x-axis. Nice horizontal line, kind of like underlining this lovely little J shape. Okay, now, this says state the domain and range. We just did this. And then this was just my question to you. This is what I was trying to show you with those negative exponents. Does the graph go over the x-axis? No, it's not possible to get a negative y value, because we would just have these fractions that would just get tiny. It would be like 1 over some huge number, but it's not ever going to be negative. So it's not possible to get a negative y value here. Now, if we do have some shifting on the graph, there could be negative y values. That is a possibility. But any of the graphs today, it's not going to go below the x-axis. Oh, to the power of x? Yeah. Okay, so if you do y equals, this one was 2 to the x, just 2. Okay, the little button above the division key, it looks like a little, like triangle without a base, is called a caret. Hit that, and that'll give you an exponent. And then x is, the button for that is next to the alpha key. The alpha key is like kind of a green color on my calculator. Just hit that, that's your x value. Anybody else? Yeah, go ahead. I'll come look at yours in a second. Okay, I'll tell you what. Why don't you guys try, let's try to make a table for this one. I'll come look at your calculator if you got a problem. This one, we're going to graph 36 times 1/2 to the x. So should this graph represent growth or decay? This one's decay, right? Okay, so I'm going to just type this, and I'll come look at your calculator. So if you're in your y equals screen, just type 36. And then I'm just going to put in parentheses, you could type 1/2 or you can just type 0.5 if you want to. I'm going to do that little caret button above the division key, and then x is next to the alpha button for the variable. And then if you want to just hit, after you get that typed in, just hit second graph. That'll give you the table. And I'll come, if your calculator looks weird, I'll come with that. Table doesn't look right. There's different ways you can manipulate your table. And if you guys are putting this on the graph, just like I said, just do your best if it's not on a nice point to just kind of estimate what you think it would be. Does not have to be perfect. The y-axis, I think, here goes by tens, but the x-axis does go by ones. And this should get, just like the last question, it should get really close to the x-axis, but it should not touch it, not go over it. And it should have the same asymptote, which is just going to be the x-axis, which is going to be y equals 0. Okay, is this the same domain as the previous graph or different? Same. It looks different on the graph, right? Decay starts up really tall and then gets down towards the x-axis really fast as it goes to the right, but it still does go left and right forever. So this domain, all real numbers, or if you want to do the interval, negative infinity to infinity. Okay, what about the range? Same or different? It is actually the same. I know it's different than the graph in terms of what it looks like, but it's the same range. Like I don't start touching any part of this graph till I hop over the asymptote. So the range should just be asymptote, and then it's going up forever, so it's going to go up to infinity. Does anybody have a question? Okay. I'm going to have you do we're going to do 4 graphs on the back, but they're all related to each other. Okay, so I'm going to have you guys graph. One of these is growth and one of these is decay. So the 4 times 1/2 to the x, this guy, because the b value is between 0 and 1, is decay. And this one, because the b value is bigger than 1, is going to be growth. So I'm just going to make the 2 tables for these 2 graphs. So I would just run, and you could do this by hand if you want to, but I would just recommend you like -2, -1, 0, 1, 2 for all these graphs today. There's no shifting going on. We're going to talk about that later. But if you want to do it by hand, you could literally do like 4 times 1/2 to the -2, write that down. 4 times 1/2 to the -1, write that down. Or if you want to, use the table. That's why I showed it to you guys. Just go to your y equals. This one is 4 times 1/2 to the x. And just second graph to get that table. You can get as many points as you want from this. All the graphs today should have the x-axis being their asymptote. And every decay function takes the same kind of general shape, kind of like a backwards J that's going to get really close to the asymptote, never touch it, never go over it. All the asymptotes today should be y equals 0 because we don't have any shifting. Every single one of the domains for any exponential function should be all real numbers, doesn't matter. And then the range, I've got this one on the graph. You guys can see I don't touch any part of the graph till I hop over that asymptote. So 0, but we have a parenthesis, not a bracket, because you don't actually touch 0. And then it goes up forever. It goes up to the left, but it still goes up. And if you got that guy graphed, I'm going to graph 3 times 2 to the x. Again, if these aren't, like I'm getting like 0.75, it's not a nice number, just kind of do your best to estimate it. And then every exponential growth function is going to kind of take the same shape. It's kind of like a little J shape. Same range as the decay function. It's just going up, but it's going up on the right instead of up on the left, but it's still going up. Is anybody having a question about these 2 at the top? Okay, now if you look at the 2 and the example at the bottom, they're identical. The only thing I changed up is the a value is negative instead of positive. So I still have like 4 times 1/2 to the x, but in the example right below this, it's going to be negative. I'm going to scooch this up a little bit. Actually, I'm going to show this to you guys at the same time if I can. All right, so if I put a -4 instead of a +4, what do you think that would do to this? Because this is the same graph, but I'm going to manipulate it a little bit and put the -4. what would me putting a -4 do to this graph? Anybody know? Like if I had this graph and I knew I was just going to change this up to a negative, how would it change the graph? What would it do to it? Exactly. So this literally just flips this over like a mirror image. So it's literally just going to come upside down. So the shape, I'm going to draw this on my paper. You guys don't have to do this, but it would literally just flip it over. It's going to go exactly the same. Everything will be exactly the same. The y coordinates will all just be negative. So it's just going to be a reflection over the x-axis. So if you guys have that table above, I had the -2, -1, 0, 1, 2. You can copy the y values, just make each one of them negative. That's literally the only difference because we're going to reflect this over the x-axis. So the graph is just going to flip down. The asymptote is still going to be the same. And most of these are, I think all of these actually, excuse me, are on nice points. So this should just flip this down. Anytime your graph flips down, it's not exponential growth or exponential decay. If that a value is negative, that falls into that category that I was calling neither. We didn't do much with that yesterday, but growth and decay, those are the two at the top. One's growth, one's decay. Anytime it points down, if the a value is negative, it doesn't matter what the b value is, it's automatically in that category of neither. It's not growth or decay because it's pointed down. Okay, now the asymptote's the same, y equals 0. In that flip down graph, is the domain the same? This graph, like if I flip that graph down, is the domain the same or is it different? It's the same, right? Still going left and right forever. It's just underneath the y-axis or the x-axis. So this is still all real numbers. Okay, now, is the range different? The range is different now. Okay, so I'm like if I approach this from the bottom, I'm touching all this graph. I'm touching this everywhere, and then I stop touching it as the asymptote. So the range here is different if it's in that neither category. You want to start with the lowest possible value if you're writing an interval. So since this is pointed down forever, my interval would actually start with -infinity, and then I would stop touching the graph at that asymptote, which is going to be 0 here. And again, I'm using a parenthesis because I'm not actually touching the 0. And then if you guys want to do the other one real quick here, I'm just going to copy the table right above. All it's going to do, I don't know why I just wrote a -1 there. All it's going to do is just take each of your y values. They'll be exactly the same numbers, but they're just going to be negative. And it's the same thing. If I flip this guy down, it's going to flip it over the x-axis, and it's just going to flip it upside down. So it's not going to look identical to the one we just did. It's going to be kind of backwards looking from that. But it's flipped over from the original that's directly above it. Now, the asymptote's still the x-axis. We're still going to get really close to that, but never touch it, never go over it. So y equals 0 should be actually the asymptote for every single graph that you're going to do in the homework too. Domain for every single one of these, whether it flips up or flips down, is all real numbers. If it does flip down, the range is going to go from -infinity, because it's pointed down forever, and it's going to stop at the asymptote, so -infinity to 0. Every single one of the graphs you're going to do today are not shifted, so it should all be 0 for the asymptotes. It should not be anything else. We'll do some shift